If I were to predict the future, I think the recording of this episode is going to be one of those that I look back on a few years from now and say, wow, I'm really glad we did it. Eric and I had the pleasure today of speaking with Adam Chapman from HeatGeek. He discusses all his insights and experiences in HVAC in the UK and how he established HeatGeek, which started out as a blog, then a YouTube channel, and then it turned into an ecosystem. I'm just going to skip my normal reading of the show notes and paraphrasing and just tell you what I circled on the little note sheet that I kept as we spoke with Adam. How to provide value to consumers, digital tools, skill building, get upskilled and get the tools to execute the best. Renew the heating industry via individual engineers. And remember, in this case, as Adam tells us, engineers are those that work on engines, so we call them technicians. Also, there's no panacea. All the buildings are different. He was found out later in life he was dyslexic, had ADHD, was also autistic. But he somehow figured out how to become empowered and unleash his way of thinking differently. We have to drop egos. We need to create a hive mind. We need to harness the magic in the way people think differently. Okay, I'm going to stop talking, and I want you to listen to this episode and see what you think about Adam Chapman of the HeatGeek and how empowering engineers and the HeatGeek approach to high-efficiency heating.
Hello, everyone. Welcome back to the Building HVAC Science Podcast. Eric here again, Bill Spohn virtually next to me, and today, special guest, Adam Chapman from HeatGeek. Adam, welcome to the show. Thanks for joining us today.
No problem at all. Thank you very much for inviting me. I've been looking forward to engage you on that side of the pond more anyway. So yeah, thank you.
Your accent, you're not from Georgia or Texas or something like that. Where are you from?
A little bit further east. So I'm from, it's about half an hour outside London in the UK. And it's kind of in the sticks, but close enough to have some fun. And yeah, we've launched HeatGeek here and it's thriving. And I'd like to share that with you guys. I think there's a lot we can discuss where we might be able to offer some insights and vice versa.
And we got to realize that it's heating. It doesn't change just because we cross an ocean. Physics works the same on both sides.
There's a lot of parallels in the industry as well, which I'll move on to. More about how engineers are viewed by the rest of society and what we can do to really unleash what engineers are capable of doing to improve this industry dramatically everywhere.
That's one thing. Terminology is important in addition to just like units of measure. But I think terminology in terms of a heating engineer, can you describe that? Because I think it might be a little different than what maybe our US-based listeners are familiar with.
Yeah, sure. So I would guess you guys would use technicians. So engineer is a protected term typically globally for someone that studied engineering. In the UK, we would term someone who fixes any kind of engine, car engine, either fixes or even operates, as per the dictionary term, an engine. It probably comes from steam engine days. So a heating engineer is someone that installs heating systems or maintains or repairs them. And we use HVAC, but way less often. Generally, you're either specialized in heating or cooling, and there's a bit of a division within our industry.
So then you would call it a cooling engineer if they're going to be working on the cooling side of things.
We actually call them fridge engineers, but yeah, still term them engineers.
How does that work if you're working on say a heat pump where it does both cooling and heating? How does that bridge that?
That's been a big change recently and a big challenge historically. We've moved more in the UK to monoblock heat pumps, self-contained heat pumps, not split systems, which has meant the installation has become rapidly simplified for any one company if they specialize in one of those two fields. And also means that our efficiencies have dramatically risen because for heat pumps, especially wet systems, which is what we're mainly installed in the UK, all of the efficiency is on the emitter side, like the radiator or fan coil sizing and distribution network sizing and how it's hydraulically connected. And it's allowed those specialists to go and really focus on that specialism and drive up to super, super high efficiencies.
So what is HeatGeek?
This is actually quite a hard question to answer. HeatGeek started off as a blog or a YouTube channel. And it grew from frustration of not having any sources as a heating engineer or HVAC technician to improve the quality of my installs, and as a business owner as well, to prove that I was the most valuable resource for them so I could charge the highest premium for the services I was offering. And I was reaching out with basic questions as to why we would do things in a certain way. And I wasn't getting the right answer. It was answers like, because we've always done it this way. Stop challenging the status quo. Get back in your box. And I don't respond very well to answers like that. So I went out to find other engineers that were also frustrated with this on social media. And this started probably about 15 years ago. And we sat up till the wee hours of the morning discussing these topics, writing them down and developing this blog, HeatGeek. All right, develop the blog and start answering the questions. The issue I found was, though, that we were still getting these same questions asked and the information wasn't getting conveyed well enough. And then I moved on to video format, which definitely helped, but still getting those same questions. So I then decided, right, that's it. We've got to make training. And this training, which really goes in from what is a watt or a BTU for your side, from what is a watt to how to size a pipe, the whole journey of what energy is and how to distribute it in the most efficient way in any property. And that bed of training helped grow the number one network of heating engineers in quality and now size in the UK. And off the back of that, we've started building digital tools and streamlining the end user side of the process with a digital experience as well. So we touch many areas: social media, digital tooling. We have like an umbrella service where the installer can get either finance for us to be announced soon, or so we have like a policing system, the MCS system in the UK, which is what all renewable installers must use. We can house that for them and it be an MCS umbrella. So the simplest way to term what HeatGeek is an ecosystem that an engineer can come in, get upskilled to the highest standard in the industry, and then be given the tools to execute their profession in the best possible way and charge a premium, which they deserve for doing that. Sorry, long-winded answer, but it is a complicated one.
It's 15, 16 years worth of development there, as you said. So is it an organization that someone joins? Is it a movement that someone follows? How would you characterize it that way?
I definitely would say it's a movement. Our slogan is renew the heating industry. We don't have much cooling here, so it is very heating focused. And it's very much been that's our birthplace, the social media interaction with other engineers, not from a corporate looking down. And we promote these individual engineers. We allow them to wear their brand. Maybe their father started the brand before. Maybe it's their business. We're letting them we're making sure they wear their own t-shirt. They charge their own rates. We don't tell them what to charge. We just simply house this system for them to operate in the best way. And we think that's the best way for a market to operate, to allow this freedom to charge different rates for different expertise, rather than trying to standardize with a digital solution that you can guarantee off the beginning. Every scenario is different. There's no panacea, which is another one of our catchphrases. It's more like almost like a union of individual engineers. We don't really have unions over this side to stand up, and a badge they can stand behind saying, I can charge more because I'm one of these guys. I'm better. If you don't have that, it's just one engineer's word against another for every customer. We're all going to be saying we're the best engineer in the country. You need a way to prove that. And so how we give it is giving them this training, and then we make sure they adhere to the code of conduct to make sure that they're always advising the most efficient systems. And we even go as far as measuring all the systems that are installed through our system, so we can see who's the most efficient installer and potentially even reach out where they're not doing so well. We wouldn't strike them off the list. We'd actually offer more training in that area. And so we create this ever-evolving platform of the highest quality network of installers.
That's really amazing. It takes a lot to stick with that. Can you tell us a little bit about the early days, if you don't mind?
Yeah, another good prompt. I think that one of the things I'm not afraid to speak out and ask questions. And I definitely don't like saying, because hearing people say, because we've done that. I think in order to make any movement anyway, you've got to make statements that's going to challenge some people's conceptions. And that might make it look like, who's this young punk coming into our industry? I've been in here 20 years longer than him, questioning what my jobs have been in the past. We've always framed it as we're part of a discussion, and I love being wrong. If we release a video that's wrong, I'll release some video and go, I was completely incorrect here. I was an idiot. This is a new information. And by doing that, you can never be defeated. You will always be the ever-growing source. So I think the early days were very personally driven by my personality type to seek out the truth and what's really behind stuff. And also just drop the egos. And if you don't understand something, just speak out and ask and get into conversation, because there's nothing more powerful or more knowledgeable than a group of engineers constantly sharing information and growing together. You will never be more intelligent or more advanced as a silo, keeping the information in your head. You will always be more intelligent with a hive mind, sharing information. And as you come across new techniques and new challenges, having that group thinking aspect that can reach out in many different directions, pull back to the hive, is an indefeatable business model.
Eric, what do you think about that?
It sounds very familiar to some of the things that have been going on here in the US for quite some time too. So I'm really interested to know a little bit more about Adam here too. We've learned a little bit about HeatGeek here. What about Adam? How did you get started in this? Were you an engineer as well? And what really landed you in this seat?
I really struggled at school. So I left school with no grades. I later on found out that I have dyslexia and ADHD. And while I was on my ADHD diagnosis, found out that I also have autism. I had no idea, which was quite difficult because I grew up thinking I was stupid. And obviously you move into plumbing if you're stupid. That's where stupid people go. Toilets, right?
Ouch.
That's what we do. That's how I felt. And it's been a real emotional journey for me. And it's been an empowering one. Because by doing that, I felt like I was worth something. And I think this was my biggest driver. Doing that apprenticeship, the 3-4 year apprenticeship, and then coming out and starting my first business at 23 years old. I always had that passion to go and start a company. It allowed me to express, do you know what? I'm worth something. I'm valuable. This is why it's such a core part of what we offer as HeatGeek, empowering individual engineers, not retiring them to the corner of society. Even a plumber, you can use the word plumber. Plumber is where you start off in our industry and you grow into the HVAC industry. You shift across. It's like a rites of passage almost. Not necessary every time, but it's just what's the well-worn trodden path. So doing that and then offering a consumer that high level of service and doing that research and realizing, actually, do you know what? I've got an engineering mind. I just think different. The feeling that gave me of being worthy, I want to share that with as many people as possible. So throughout the years on the forums, as I was approaching my customers and wanting these extra bits of information, I saw other engineers come in, get excited by this information that was circulating. And I watched their business, especially the ones that had a lower ego and willing to ask the questions, their businesses just absolutely rocketed. And now our network is full of like the top businesses in the UK. And watching that growth in small forums and being part of that and even hearing the like jubilation, like, thank you, you've transformed my lives, is honest eye-watering. So that's what this industry has done for me, and that's what I want to offer in HeatGeek for other engineers, and that is what we've been doing now, and it's really like that acceleration part. So, yeah, if we're going really deep, which I've already gone there, early life was a struggle. I basically didn't really finish school, and then I found engineering and HVAC. I worked a lot in commercial, which I think was really good for broadening my understanding of what's available, of different techniques and things out there. Historically, our industry in the UK is natural gas boiler or furnace driven. Condensing though, we mandated condensing technology in 2005, so we're quite well down the low flow temperature path. And in the last 3 years, heat pumps have just taken a massive upswing, which is why we're mainly wet systems, because it's systems connected to radiators. And we've ridden that and sat on that and used it, just been part of it as part of our drive. And then I've got 3 kids.
That's great to me, and no shame in not completing school for anybody. I think it's great. I don't think school is for everybody, but if it's for you, great. Go do it, be great at it, and go do something productive with that afterwards. But if it's not, that doesn't mean you can't be productive in society, as you've shown, as many people have shown. We've talked to a lot of people on the show, and we have a lot of friends that maybe haven't gone to school or have taken alternative paths to be productive.
I think the school system, certainly in the UK, is totally broken. So I always have my hand up in science for the answers, and I'd be nailing it. I get like a questionable look afterwards if you read that somewhere. And then when it comes down to actually writing your thesis, I'm using English to write down my thesis. You're marking my English skills, my reading and writing skills. I'm dyslexic. I can't really read and write. And when you look into it and you find that such a large percentage of engineers are dyslexic, but really good with their hands and thinking about 3D mental models in their heads about how things are working without even having to write it down. You understand that some people just think differently, and those people are magic. If you can harness the magic of the way they think, you've unlocked something that generally our industry maybe, but generally the world just ignores. And even if school realizes you're not very good at something, you generally get more help in the areas you're not good at, rather than accelerating the things you are good at by making individual people rather than a grey sea of average at everything people. So yeah, hopefully if I could inspire some people to realize that they're just a bit different and actually there's something in them to do something special, then that would be definitely an achievement from my lifetime if I achieve anything at all.
Very cool. I want to ask a little bit more here about, you mentioned a 4-year apprenticeship program, and US and UK, very different systems, it sounds like. Is that a national thing that you would go through in the UK to then become I'm assuming some sort of licensed or journeyman, or how does that work? How does that system work?
It used to be, and then since 70s, 80s, it's petering out and very little people go through this full apprenticeship now. I actually had the opportunity to either do it or just go through the day courses, etc., to get a license. But I wanted to do it because I had the hunger to just be the best I could possibly be, to prove myself in some kind of way. I think we're going more and more to that model of not necessarily doing apprenticeships. HeatGeek, though, undermining that whole thing and introducing digital training. So all of our training is online. And I truly think that there's an opportunity to harness that with working with different engineers, maybe using photographic evidence to create a new digital 2.0 type apprenticeship that can certify people, and where the community polices itself and they can police each other, harnessed in this digital front end. So in the UK, I know less about the US. I think there's a lot we can improve on, and there's a ton of tech out there now that can make it a ton better than it currently is.
Something that's been happening in the US for a while, and I want to say it's about 2016, is the Brian Orr and the HVACR school. If you haven't heard of that, I encourage you to look that up.
That down now?
Yeah, it's hvacrschool.com.
R stands for fridge.
Right. Digital is the way. But yeah, does he do much with like communities, and does he get these guys working together and stuff?
Yeah, like 50,000 people in the community, maybe more than that now. And this coming February, it'll be the 6th year for something called the HVACR School Symposium, which is a limited attendance event, only limited by the fact of facility. There's also live streaming for a very low price that you can either attend and live stream or see the videos afterwards. In fact, you might still be able to see this year's, the 2024 version, which would be the 5th annual. You could sign up and probably watch the videos, and there's hundreds of hours of content there.
Amazing. Thank you so much for that. Yeah, anything we can take from your side would be absolutely brilliant. So,
and give to our side. I think we're making a connection here.
100%. It's good they're so isolated, our two industries. I'm on a few US HVAC Facebook groups and stuff like that because I'm really sad and that's where I spend all my spare time. But I love it.
Our listeners can't see this right now, but there's 2 other people raising their hands.
You've got to love what you do, right? We spend most of our life doing it, and we work very differently to you guys. There's some things you guys do incredibly well, which we need to learn a lot from. And I think there's a few tricks that we can show you guys too. So I'm looking forward to seeing where that collaboration goes.
Here's another question for you. And this is something that has been happening a little bit more in the US, I'll say probably over the past, Bill, probably 5 to 10 years, is we're starting to see a combination of the HVAC technicians, the HVAC companies, and the building performance companies. We're starting to see that mentality combine and really work together and realize that, hey, the HVAC is just a piece of the larger comfort system picture. And some of these companies are really starting to dig in, saying, hey, we're here to solve comfort problems. Not only do we have to work on the mechanical systems, we've also got to work on the shell structure, and we have to pay attention to both in concert. Do you see that happening in the UK? Is that something that is occurring?
I think we've actually swung both ways very recently. So it's a bit of a funny way to say it. For a long time, we were going down that road. Like, this is a holistic point of view. You need to look at insulation in relation to providing energy for either heat or cooling, mainly for heating, as I say. However, recently, certainly through the installations we've been doing, we've proved, so we have the oldest housing stock in Europe. My house is 100 years old. and not that well insulated, the efficiencies you can achieve with wet systems and heat pumps are so high. Often, if you're just looking at CapEx and OpEx, you're better off just chucking in a wet heat pump system today. As I say, my system's 100 years old. My house is 100 years old. My system's a year and a half old. I'm at a SCOP. I think you guys still use SCOP, SCOP, or efficiency of 475%. So I'm only paying for 1/5, really, of the heat energy that we're producing. And we're now starting to see SCOPs of 5 on 100-year-old buildings. The new buildings, they're easy. They're already well insulated. You can get high efficiencies on those. We're proving that actually, yes, you should consider it, and you have to consider the building structure and air tightness and insulation levels in order to size the equipment. Because if you're not sizing the equipment right, you're not getting a SCOP of 5, no way, or a 500% efficiency. You have to size it. And when you measure the load, and when you do that, you can see if there's any easy wins. Rolling out some like loft insulation or whatever, that's going to take like no time at all. You may as well just do it. But when we're talking about actually fabric upgrades, like in the walls, and you look at how much that costs and weigh it out, yes, it's the right thing to do, but is it going to be a barrier for, we're very much carbon driven over in the UK. We prefer them like the carbon's more, if they end up in the same space or even lower running costs at the end, we would prefer the lower carbon option, which often is just get heat pumps installed everywhere. So I think the reality is, though, every case is different. Every demand is different. Some people care about carbon. Some people don't believe or give a toss about it. What everyone cares about is the running costs. So if you can build a system that can look at all these variances, which is where we come in with digital tooling, and then the homeowner, along with the engineer, is empowered to make that decision, that's where the gold is. So what we have is we've got a digital tooling where we scan the home when we go in, that it reads all the building dimensions, and we auto select external, internal walls and put in the fabric quality. And at the end, we look at their potential upgrades, whether it's fabric or heat pump, and we'll give them like a slider. So for a heat pump, you might want to design the system for different flow temperatures, the lower, the more efficient. And the homeowner or engineer can slide this up and down and watch the CapEx and OpEx move around, and they can get the quick understanding of what's going to be the best way to approach upgrading their home. So for me, it's like corporate want a one size fits all copy paste solution, and engineering just doesn't happen that way. It happens depending on the person, how they use the home, and the home type itself. I think it's more pronounced over here because we have homes that are 300 years old and homes that are 2 years old. And even the homes at 300 years old were upgraded at different times. They got different generations of plumbing in them. So every home is so different that we have to empower the engineers to understand what they're doing so they can make engineering judgments while they're doing it. Not give here's a box that you can install. That just comes out with super high efficiency. It's here's how this fundamentally works. Here's how to fine tune it during the installation process. Now go away and you pick what's best for every single scenario. And here's some digital tools to empower you to do that. So for me, it's about bringing back education, engineering, and not oversimplification. So although we give digital tools, it's under the understanding that the number one person in this, we're calling it the transition to electrification in the UK, is the engineer on site. Not the engineer's boss who hasn't been there or some designer in a different state or whatever. It's the guy who last had his hands on the pipework or emitters or whatever. They're the one making sure this stuff's put in properly. And again, slightly more increased in importance for wet systems than air systems, because that's predominantly what we are here, but that's what we're all about.
Yeah, so in the U.S., we end up with a lot of forced air systems, especially ducted forced air systems, which is very different from what your wet systems where you just have radiators. Do you do a lot of panel radiators or things like that, or is it a lot of baseboard radiation where it's just coming up the wall?
Mainly we do underfloor heating, which I think you call in-floor, right?
In-floor heating, underfloor heating, yeah.
And panel radiators, as you say. We also have column radiators, which I know you guys have there, older Victorian-style looking radiators. So mainly those. Also forced, so radiators with a fan inside, convector radiators. So we kind of use all of those. Because we have older homes, generally speaking, the air-to-air forced air doesn't quite look right in our Victorian ornate type housing, and people just aren't used to it. The other thing is, it depends on things like the thermal mass of the building. So if you've got a higher thermal mass, you kind of want to work with that. Working with air, you have to put more air energy in or less, and it's hit and break, whereas we can do low and slow with a larger thermal mass. So again, depends on all the variables, what the customer wants, obviously, and there's no right and wrong. There's no panacea. So it's about understanding those variables. We are going to be moving into more air-to-air in the UK soon, I think, though, because the advantage of cooling as well in a warming country is increasing in demand.
Yeah, I've heard that just in the general area of Europe, you're seeing a lot more cooling being put in. I know I've got some family in the Netherlands, and they're telling me that it's like a year out or more to try to get air conditioning in their house, or even a mini split, a ductless split system in their house. And I'm like, holy cow.
Yeah, there's a bit of a bomb coming, I think, because we've got all these monoblock systems for wet heating systems, and we're not really increasing the fridge engineer repair base. So we've got all this fridge going in and someone's going to need to fix it when it goes down. And we're starting to look at that now, but it wasn't our area previously. We were watching and someone's got a big opportunity ahead of them in the UK.
So in these monoblock systems that you're putting in, are they reversible to where they can make chilled water and heating water, or it's just so they are reversible?
Yeah, they're reversible. Generally, they reverse for defrost mode anyway. If we want to reverse ours, normally we're not pulling the fabric right apart. So we may have exposed pipework that isn't vapor sealed and we don't want to get that condensation. So we're very much limited to sort of a more passive cooling type temperature.
It's hard to do cooling when you're talking about radiant cooling because you have to manage, if you've got humidity, and you have to manage that humidity so tightly so that you don't get the condensation just randomly dripping on the floor.
Yeah, so typically the heat pumps that we install, Valent, I don't think you have the Valent brand over there. That's our top selling heat pump at the moment. They measure the dew point and they track the dew point, and you can offset it higher or lower, minus a degree, plus a degree, depending on how brave you feel or how well it. Again, education, engineering, you can tune it to what you need.
Yeah, so it's got to track that dew point in the space and then control the water temperature in those radiators to be above that dew point so that you're not condensing.
So it's just going to, depends how brave.
So, and I know you're going to give me answers in Celsius. What kind of, I've got a converter sitting right here. I'm going to convert it for all of our US listeners. What outdoor temperatures are you dealing with in heating and cooling scenarios? So what we would call it design temperatures.
Yeah, no, that's the same here. Design temperatures, typically we'd be designing an average of around -2. However, there are like -8, -9, -10 up in Scotland, but the national average is around -2, maybe just over -2, something like that. If and when it does sink just below that, if we've got the design dead on, we may see a degree drop in the internal temperature. However, in the measuring of the heat loads, generally, we find that they're massively oversized still because of all the contingency that's built in around measuring heat load, which again is something we're measuring as we go around and scan these homes. We measure every install and we feed it back into our software at the beginning. Eventually, at some point, we can do a heat loss off a postcode for an area code. We're well on our way there now. We can do that online already off a postcode. But yeah, so not mega cool. The other reason for that is -2, sorry to interrupt, Bill, is that we're surrounded by water, huge thermal mass. So we can't get that cold. And likewise, we don't get that hot. It's quite stable in the UK. So we're pretty lucky, really.
You mean the external water mass of the oceans and seas around you?
Yes.
-10 for our US-based Fahrenheit listeners, that's about 14 Fahrenheit. And a lot of times we in the US, so we're actually having to design for considerably lower temperatures a lot of times because we're designing even down to like -10. In my area right now, mine is 5 Fahrenheit, which would be -15 for you guys. That's my design temperature. And it's not unheard of to go to negative Fahrenheit, which would be like -23, 25 for you guys. So
that's crazy.
We do deal with considerably lower temperatures here at times.
Yeah, I think our challenge is really mainly around the building age. So 200-year-old building at -2 is probably the equivalent of -20 Fahrenheit Celsius. These are all the variables that are involved. This is why it comes back to education.
Yeah, and it's interesting, the engineering methodologies that we approach, different methods to solve the different problems. So let's go back to HeatGeek here a little bit. You've got a lot of tools built in. You're talking about scanning the buildings. Looking on your website, it looks like you're using either like phones or iPads or something like that to do that scanning. Is that the LiDAR in there that you're using?
If someone's done our training and they become an official verified HeatGeek, we send them out an iPad. So the experience is the same for all of them. If we have a consumer comes to us, they'll punch in their postcode. We give them a very quick heat loss calculation with a cost and a payback immediately, right there and then. So the engineers don't waste time. They know roughly what ballpark they're looking at. We're trying to kick out the tire kickers, etc. If the customer's happy with that, that gets sent through to their local HeatGeek's iPad. They take their iPad out to the property and they go around every room, scan every wall. It measures all the windows, all the floors. It looks for things like chimneys to see if there's extra draft going up the chimneys. It'll know if it sees an external wall because it's got a window in it. And it adds all those rooms up and makes a digital twin of that property. And then from there, we also add the emitters, either the in-floor or radiant panels. And that's what gives us the power requirement to power provision fixed point that we can slide around to look at the CapEx, OpEx. What lowest flow temperature can we get this system running at to drive up this efficiency? And what's the minimum amount of emitters we can get away with upgrading? Or should we just upgrade more because we know the efficiency is going to pay off? And then most importantly of all, after we have like a buying club, so we get the heat pumps a bit cheaper, etc. for the installers, we monitor the install. That's the key part because that feeds right back into the beginning where the postcode was entered on the website to drive in the accuracy ever more. And even the room scan will get more and more accurate by closing this loop. There's that digital tool. But again, as we're monitoring, we're also monitoring the installers. If I find out that Joe Bloggs in Manchester is not doing very well on 63-year-old homes, I'm going to send in the 63-year-old home module. So our training is also embedded into the experience. So we've got this ever increasing, improving feedback loop.
Very cool. So you're constantly watching the work that your people are doing and then saying, hey, let's do a little more education on this section here. Maybe you're struggling here.
One interjection here, just to make sure listeners are hearing, when you say CapEx and OpEx, that's capital expenditures and operating expenditures, which is a commercial term used a lot here. So listeners, if you haven't heard that, it's equipment cost and running costs. That's the translation.
I need to excuse myself there because if you spoke to me 2 years ago, I would have never been saying that ever. 2.5 years ago, I've missed this from the HeatGeek story. I was approached by an ex-Apple employee. He was quite high up in the UK. And he was looking for something a bit different and to get out and do something more meaningful and was a big HeatGeek fan. And so a couple of years ago, we went into business together and he's actually the CEO now of HeatGeek. I cannot manage people. I don't understand. I'm still terrible at writing emails. It doesn't look very professional. So this is his language reflecting back out, not mine. So going back, we measure the installs to look for where we can improve training as an aggregate for our whole workforce and for when any new information comes in and on an individual basis, but in a supportive way. We also give them the opportunity to gamify. So the top 5 efficiency installers, they'll be going on the league table. I'm sure you've got gamification over there. We have relative SCOP. So if your efficiency was projected at 4.1 or 410% and you've achieved 420, you get like a 1. I don't know what that works out as, 1.02 or something relative SCOP. And I think that's a challenge. You can't do efficiency for efficiency because some buildings are old, some are new, etc. So yeah, that gamification, and that just comes back to the community aspect, right? Again, which it sounds like you guys are well on the way to already being there, which I'm looking forward to seeing.
And the SCOP, again, to make sure listeners, that's seasonal coefficient of performance, probably something close to our SEER, Eric. And I can't say like the seasonal energy efficiency ratio.
We use SEER for cooling. SEER is the cooling efficiency and SCOP is the heating efficiency for us.
HSPF?
We use COP and HSPF on the heating side, which is...
Right, we use HSPF.
There's a lot of different calculations out there and different ways to slice up that pie. And
we use the COP as well, coefficient performance, but seasonal is just the additional S. And we kind of want to get rid of that, to be quite honest. So we've started saying to customers just overall efficiency and just present it as a number. This is why I'm saying 400. I think overall efficiency is fine. That's the fiscal efficiency. We're not ignoring thermodynamics. We're talking about the fiscal efficiency of the system.
A lot of different ways to present that to the end user, the customer out there. And some of them can be a little confusing at times.
Right. What matters to consumer more than the running cost? So if your efficiency, that's where it should come down to. They don't care about thermodynamics, or most of them don't care about carbon or anything like that.
So this contest, is that publicly displayed? Can anyone take a look at that?
In the UK, we have something called heatpumpmonitor.org. You should check it out. That's a third party that's not part of us. But if you go onto that website, you'll see a league table of, 100 or 200 installations. And at the top, you'll see a little HeatGeek symbol next to the people that have taken the HeatGeek training, which all obviously gravitate towards the top, and as you go down, they peter out. Some of them aren't working or something right at the bottom, but that's the third-party league table. We have stuff in-house, which probably is going to be available soon, but our aggregate efficiency is 4.3 or 430%, which opposes the national average efficiency of 280% for a heat pump installation. And that's a wet heat pump installation, much easier to measure than air-to-air. So that just shows how markedly improved we are on the national average, and that the training is the right stuff.
How are you grabbing this data? Because I'm looking at the website now and seeing the data length is 90 days. So there's some continuous monitoring going on?
If you click on that, you can take that to 365, but we do 90 days as well because we want to look at the seasoned individual, because some may perform better in different seasons than others. They have hot water to factor in, etc. So it's the ability to drag into different timeframes. And also you'll notice you can partner with different tariffs as well to compare those running costs. So it's really a window in. So if you click on any one of those installs, you'll come up with a bar chart, and you'll see a dashboard. You can click into the dashboard and you can literally go down to the second and have a look at the COP at any one time and explore each day. So it's not great to use yet, but all the data's in there. You can literally find out anything you want from there. I would definitely advise.
One glossary thing here. Tariff would be the cost per energy unit.
Yes, that's right, yeah.
People think if you're a tariff like it's a tax, perhaps, and it is in a way, but
yeah, it's full of taxes probably, but I think that's a key part. Demand shifting, which is that's a whole subject in there, and how it can lower efficiency and how they work.
Time of use rates and things like that. Yeah.
Those installs there, they've had third-party monitoring installed. So they have a heat meter installed on the pipework going out to the emitters. So measure flow rate and delta T and triangulate the energy output versus, an electricity meter, obviously, to measure the delta between the two. That's a big thing. And this is where a lot of the education comes from, is studying these systems and these engineers sharing knowledge with each other.
That was a question, a flow meter with a delta T measurement and then the electrical. So basically the input and the output are relayed. What time chunks? Just curious, like how often is
I think we're down to 10 seconds now, actually.
Wow.
That's low.
Locally, and then uploads it. It's moved on quite a lot, so it's very helpful.
Who pays for the monitoring?
So that's passed on direct to the customer. However, to be on that league table, that's additional monitoring. So we monitor from the heat pumps because they already have these meters and things in them. Most of them have a mid-meter these days, the good quality ones. That's if they want the third-party monitoring. And we actually need this anyway, because what we found is the individual manufacturer's monitoring can vary in accuracy quite a lot. This has been found to be a lot more accurate. And we're measuring the two against each other. And with more and more data, we're starting to normalize it and find out what's real. And so at some point, we won't really need additional monitoring. We'll just understand the monitoring you have in, and we can adjust for it in that situation.
Along the way, has there been pushback? Something that made you stop in your tracks?
From, I think how we started earlier on, the pushback for me was from a big chunk of the industry that didn't want change. They saw it as a threat to their livelihood. It's how they put food on the kids' table. And when you see change like that in your business, your heart, the reflection of you, you're going to experience fear. And I think I saw fear of, what do you mean I don't know what I'm doing? And does this mean my business isn't as good, or you're chatting rubbish? That's just been a constant battle, to be honest. That's a constant resistance that I have to turn up the pump pressure for.
And a little bit of delta T too.
Yeah, exactly. But it's also how we market. If there wasn't any yin and yang, if there was no conversation, if there was no fighting going on, we'd have no outreach. There wouldn't be anyone listening, no one watching the YouTube channel. The biggest proponent in the UK against heat pumps is a guy called Skill Builder. He's got, I think, nearly 600,000 subscribers on YouTube. A big personality. He's been on loads of TV shows on the main BBC channels and very well known. And he was talking crap about heat pumps for a very long time. So I did a response video pointing out all the bits where he was chatting rubbish. Cut a long story short, I had him in our showroom. We had it out on camera. That went quite well, but he still held his view. And then as time's gone on, I eventually got out to one of his installs where he was showing this install. This doesn't work. It doesn't work in our standard housing stock. This 150-year-old home. It's not working. It's double the running costs that they previously had with their gas boiler. And I went out in half an hour. I said, turn on the camera for her there. We're just going to record it. And I got there and I pointed out fault after fault after fault of how it was installed. Not the heat pump, how the system was installed. And 1 or 2 months later, we went back, swapped it all for free of charge. And that system, 150-year-old house with single skin brick wall, so it's like a radiator, there's no insulation at all, is at 480% efficiency. So heat pumps work very well when they're installed well. And his hot water's at 470% efficiency as well, which is pretty high for hot water. He's now a big HeatGeek fan, to say the least.
Very cool. It's always nice when you can go and prove what you're doing, and in such a national scale, or a very national but very visible scale like that.
That install is on that heat pump monitor. You'll see it's in the area called, if you go to that heatpumpmonitor.org, it's the one that says Ashstead. It says it's at 4.7 at the moment in the last 70 or 90 days. It's only been in for 90 days, but if you're there already, you're only going up from there. It was installed in cold weather. So I think that's probably going to be about that after the end of the year.
Very cool.
There's so much here.
There is a ton here. Like, my brain is swimming right now.
I've got more to tell you as well, but I don't know how to fold it in.
I think we're going to wrap up for our listeners. We're going to put some links certainly to HeatGeek. We'll put the heatpumpmonitor.org in there. Put in your LinkedIn, because I think you're often posting there too, content that's very worthwhile. And I'm going to give you some homework too, to go look at hvacrschool.com.
Yeah, very exciting. That's not homework. That's hobby material.
Okay, hobby material. And then another thing that a couple people are working on here is something called betterhvac.org. That's more about the quality of work. It's just a nascent movement we started earlier this year, like in February this year. Have over 160 contractors. We're trying to make something of it initially and doing it all part-time. So there's no funding into that, but it's just a concept that we think is necessary. Seeing a lot of people that care so much, want to learn continuously and work ethically.
That's right. And these people that do that, they deserve that recognition. So this is why it's so important to do this kind of thing and put these people on a pedestal, because that's what ultimately drives up quality and gives everyone a fairer deal.
We're going to be in touch more often if you can stand it.
Please do. Like I say, we're going to be making more US-based content very soon. I want to do maybe a European install style versus US style. Maybe you can help me make that video installation.
I think we can.
Yeah, that'd be a lot of fun.
Very good. Closing thoughts for our listeners, please.
My closing thoughts are, 1, subscribe to the HeatGeek YouTube channel. I guess I said it peppered throughout the whole video. Engineers, the boots on the ground, the guys doing the work, or girls doing the work in homes, they are the key to electrify America or UK or anywhere else in the world. It's not necessarily about corporates that want to make a solution and put it down on an industry. It's about coming from the roots and fixing their actual problems. That's been our thing the whole way through, which is why we're authentic and real and why we're growing. So don't put down these people. You need to hear these people, put them on a pedestal, the complete opposite. Don't try and oversimplify for them. Help them fix their pangs. So I suppose that's mainly it. And just a call out for the US to, if they want to look at super, super high efficiency hydronic systems. I know you guys have hydronics over there. I think we're a level above that personally, if I may say so myself. Look at the HeatGeek channel. We go into deep detail about how to refine these low temperature systems and increase comfort. That's not a risk of comfort. Increase comfort and really drive down running costs. We're going to be moving into more air-to-air stuff soon, or forced air. And watch out for me stateside. And you guys, it'd be great to keep in touch with you too and be part of the journey. Come over and see you.
I'm super interested to learn more about these panel radiators. Radiant is obviously, for heating, the most comfortable system, because it's radiating it towards your body rather than, and with forced air heating. But anyways, that's a whole nother show.
Yeah. I'm happy to come back on.
Definitely. We will have you back. Thank you, Adam.
Thanks, guys.
Hey, thanks for listening to this episode of the Building HVAC Science Podcast. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're trained pro, go right ahead. And if you're not, please consult with and hire a trained pro. And that would be a trained pro in your country, because we've gone international now. The Building HVAC Science Podcast is a production of TrueTech Tools Limited. Full disclosure, I'm a co-owner of TrueTech. The opinions voiced are those of my guests, my co-host, Eric Kaiser, or myself, depending on who's speaking, of course. And if you're in the market for tools or test instruments mentioned in the podcast, take a look at what TrueTech Tools, our company, has to offer. TrueTechTools.com. And you can use the offer code HVACBS for a nice discount. I want to thank you for listening to this episode of the Building HVAC Science Podcast. If you're not subscribed, please consider doing so. If you have any comments, feedbacks, feedback's plural, I guess. Want to suggest the topic or just reach out? Contact us at marketing@truetechtools.com, TrueTechTools.com. As I said at the outset of the episode, I think we'll be meeting with Adam again because there's an awful lot to be learned on both sides. Everybody, take care.